We're going to do our first set of video tutorials on section 6.4, factoring and solving polynomial equations. We're going to do 4 separate videos. In the first video, we're going to look at the difference in sum of cubes, since this particular factoring pattern is very common. So the difference in sum of cubes come in 2 forms. The sum of cubes is where you get a cubed plus b cubed. The difference of cubes is a cubed minus b cubed. These are just 2 patterns. We're going to grab this pattern, okay, and apply it. So we need to know what the cube root of a cubed is and the cube root of b cubed in order to push this through. So we're going to be following this first one right here as we do this. So let's figure out what the cube roots are here. 3, not a perfect cube. Neither is 81. So let's go ahead and factor out a 3. So if I factor out a 3, I get x cubed in the first term and 27 in the second term. So this is just a common monomial factor. I pull a 3 out of both terms. Always look for that because it simplifies this math over here. Now we've got 2 perfect cubes. So I have the 3 still. I'm going to multiply that by x cubed plus the cube root of 27, which is 3 cubed. Now, if it helps you, we now know that a is x, sorry, and b is 3. So with that, let's apply the formula. So the 3 is going to always stay there, and we have x plus 3. I just like to see that the x and the 3 and the plus come down in this first one. Then the second part of the factor is where it's going to change. We're going to take our first term, or a, and square it. Then we're going to take both the terms, the x and the 3, and multiply them together, but here is where the subtraction is. So this becomes 3x, and then last but not least, we're going to add the square of the second term, or b. So this is 9. Okay? And we're done. I'm going to go ahead and grab a different pen, and I'm going to do a quick check just to show you how this works. Okay? And I'm going to FOIL this. The x I'm going to push through first. So when I check, I get x cubed. X times negative 3x gives me negative 3x squared. X times 9 gives me positive 9x. Now I'm going to FOIL this 3 through, or push this 3 through, and I get positive 3x squared. I get minus 9x and a positive 27. So what happens here is we get to lose terms. 3x squared, negative 3x squared, gone. See ya. Out of here. 9x, negative 9x, they cancel out. What we're left with here in just our proof is x cubed plus 27, which is what we started with up here. And then we could push the 3 through if we want, but I think we've made our point. This is just a check, not required in your work. What I want you to get to is this bad boy right here. Okay? Put a box around your